as well get started. It's 4 o'clock, and welcome everybody here in the room, and welcome to those online that are coming into the room. You can see them populate the Zoom screen here. I think we've got a big contingent online today, which is great. This is our first Dean's Lecture for the year 2024. So you're privileged, Emily, to kick us off. So just a little background. I think everybody is aware that these Dean's Lectures are an opportunity for us to learn firsthand from newly appointed and promoted professors and senior scientists, and a chance for them to communicate with us about the work they're doing and for us to get to know them. And it's especially great for people outside a professor's department, discipline, area of interest to come to these lectures, because it's really a great way to learn about what your colleagues are doing. And they're always phenomenal. And I'm particularly looking forward to our presentation today. We're in for a real treat as we welcome Dr. Emily Gurley. I should say Professor Emily Gurley. Emily is a distinguished professor of the practice in epidemiology with a joint appointment in international health. And for more than 2 decades, she has focused on understanding infectious disease transmission, developing novel methods for outbreak surveillance and investigation, and studying the best interventions for disease prevention. She has examined everything from zoonotic infections to arboviruses to vaccine-preventable diseases, a really impressive spectrum of work that you'll hear about. And truly, you never know where you'll find Emily. You know, 1 month she's in her office right here in Wolf Street, building an online course that will enroll millions of people. Of course, I'm referring to the contact tracing course, among others. And then next, she might be in Bangladesh, working under the cover of night, collecting saliva samples from bats. That's the life of an epidemiologist, as we've come to know, and Emily excels in all aspects of it. Like many of us in public health, her path to where she is today was not a straight line. Emily grew up in rural Georgia, and her father was a firefighter who unfortunately died in the line of duty when she was quite young. When Emily's mother remarried a doctor who was in the foreign service, Emily found herself moving from the foothills of Appalachia to Bangladesh. There, she quickly had to lose her thick Southern accent. I can't picture you with a Southern accent, but she had to lose that accent so people could understand her in Bangladesh. And as she grew up, she'd go on to live in Honduras, Yugoslavia, and even a Swiss boarding school. Back then, she really didn't think, I'm told, much about being a scientist, let alone an epidemiologist. You probably didn't even know what an epidemiologist was at that point in time. I'm told she wanted to join the circus or become a ballerina. I mean, who wouldn't want to become a ballerina? But a desire for travel led her to the Peace Corps right after college. And for 2 years, she lived in Romania, working in the country's first hospice program. That lit a spark for her, and she headed to Emory. She'll come back, but she went to Emory first to get her public health degree. But then she saw the light and came here to Johns Hopkins, to the Bloomberg School, and got her PhD. And she's built just an extraordinary career here at the school. She has made discoveries, launched novel strategies, and worked tirelessly to bridge the gap between research and field work. She brings a holistic One Health approach to addressing emerging and preventable diseases, helping us to see the big picture and pursue effective, lasting solutions to vexing public health challenges. So let me just give you a few examples of that work. Emily was part of a team that helped uncover how the lethal Nipah virus was spreading in Bangladesh, tracing it back to those bats who were feeding on sap from date palms. Just love the image of that. Interesting. Those findings led the groundwork for years of research on both major outbreaks and spillovers, providing the foundation for future prevention. And in fact, the first human vaccine trials for Nipah are just being launched now. Emily is also the co-director of the CHAMPS project, which is based in a sub-district of Bangladesh, where child mortality remains stubbornly high. Excuse me. Her team works with families to get consent for taking post-mortem tissue samples to better understand and document the causes of childhood mortality. Now, that's an incredibly delicate and I'm sure at times painful task, but one that is helping us move towards better knowledge that can save other families from a terrible heartbreak. And as we are all very much well aware, Emily emerged as a leader during one of the greatest challenges of our time, the COVID-19 pandemic. She helped establish the novel Corona Research Compendium, which rapidly curated and assessed emerging COVID research, an effort that was desperately needed at that time of many, many unknowns. She also led the development of our online contact tracing course, which would eventually enroll more than 1 million people, not just here in the US, but around the world. It was quite amazing. Thanks to Emily and so many others in our Department of Epidemiology, they leveraged their strengths to serve the world at a time of tremendous need and raise the profile of our school's work in lasting and very meaningful ways. Emily was awarded the Bloomberg School's Shikani El Hibri Prize for Discovery and Innovation for her work in COVID-19. She was also elected to the board of directors on the American Society of Tropical Medicine and Hygiene. Honors like these really do reflect Emily's years of hard work and her impact on the field. And way beyond her research, Emily would tell you that she considers training others to be one of her most important contributions and her passion, because she strongly believes that contributions to mentoring and helping others find their own paths will shape the future of epidemiology and of public health more broadly. Before going on, I just want to recognize that Emily's husband and 2 children are with us here today, and we just are so pleased that you're able to join us and hear about all the wonderful, you probably don't know half of what your mother does, but it's great to have you here. So Emily, Professor Gurley, we are so grateful for all you've done for the school and for the field of public health, and we're so excited to hear from you today. Professor Gurley.
Thank you for the lovely introduction. And thanks to all of you for taking time out of your busy days to come hear what I have to say. I'm going to talk to you about some of the mysteries and most difficult problems that I've been working on throughout my career, and tell you a bit about my life story as I go, because as you'll see, they're difficult to disentangle. And Dean McKenzie already gave you a bit of my life tour, so I can go through this quickly. I was born in Georgia, as she said. And then when I was 11, moved to Bangladesh and gained a wonderful stepdad, who's actually online too. And as you can imagine, having never left the country before, barely ever left the state, this completely changed my life. And I went on to go to try to figure out many new cultures and places every 2 years, moving around Honduras, Switzerland. I went back to Atlanta for my college. I studied history. I actually said science. I wasn't really interested in that. It sounded kind of boring at the time. And then decided to join the Peace Corps because with a history degree, well, you're not really going to get a job doing much. And so I wanted to try to make myself useful. I moved to Romania. And two things happened there. I found public health, which was really important. And I also met my husband. And in Peace Corps circles, that's known as the ultimate souvenir. So I won on both counts. I went back to the US to pursue public health, and that's where I found research. That's where I realized that collecting and analyzing data was the most interesting thing I could think of to do in the pursuit of public health. So Eric and I married, and then he was offered a job working in Dhaka, Bangladesh. So I moved to Bangladesh for the second time. You never know how many times you're going to move to Dhaka, but here it was twice. So that was us. So this is the first 28 years or so in a nutshell. So I moved to Dhaka, a recent graduate, really interested in research, and what am I going to do with myself? How am I going to make myself useful? I started talking to, here, that's sort of what Dhaka looked like around that time. So I started talking to people who were doing public health research there. There was a lot of public health work. I met someone named Rob Bryman, who agreed to give me a job. And I got a job working at the ICDDRB. David Sack was the executive director, as it turns out. Side note, the first time I lived in Dhaka, I went to school with his kids. So it's a very small world. I joined the program for infectious diseases. Well, first, let me just say more about ICDDRB. They're famous for developing ORS, which, I hear people around here are interested in saving lives millions at a time. I give you ORS. And I joined this group here, some of this group, the program on infectious diseases and vaccine sciences that had newly started. I knew virtually nothing about infectious diseases. That didn't seem to deter them. They thought maybe I could make myself useful. So there we were. And I can tell you exactly what I was doing 20 years ago today. I was on my very first outbreak investigation here in Golando. And this is my good friend, Jahangir Hussain. We were colleagues for many years. There was an outbreak of encephalitis, mostly children. There were about 8 or 9 cases at the time when we went out, and most of them had already died. So it was something very serious. And our job was to figure out this mystery. We had massive missing data problems. We needed samples. We needed a lot of information to try to figure out what was happening. I got the invitation almost by chance. Our group was asked by the government to go, and they said, well, Emily, do you want to go? I was like, what am I going to do? I said, you'll find something. You can help with logistics. At least you can learn something. See what you can do. So here I was, and I learned a lot. One of the things that, as we were investigating what these children did, we tried to find all the different ways that they could have come into harm's way. And they told us that they used to have funerals for all the poultry that died. So whenever a duck would die or a chicken would die, the children would hold a funeral and bury that. And there were these kinds of reports in the media, and we thought, well, is this some sort of bird influenza? There were lots of ways that these children actually could have come into harm's way. So we went about our investigation. This is reviewing case control data forms by candlelight with our team. So we were trying to close that information gap. What were people doing when they got sick and before? We collected sera, so collecting samples to try to figure out what they had. We collected samples from animals as well. Lots of different animals, including this little goat here, poor guy. I necropsied a shrew. I got to do things like wildlife sampling. And this was amazing. I loved it. It was such a compelling thing to do. the outbreak was a tragedy and there was a real gravity to the work. But if there was something we could do to figure out what had happened, that seemed really meaningful. I wanted to do that. I made a lot of friends. That's Joel Montgomery. We still work together today. He was an EIS officer at the time. And I made good friends with the people who lived there. We were there for weeks trying to figure out what the outbreak was. And these were the ladies that we saw every day. So we learned about their lives. They learned about ours. We were very, very curious people. So we always had a lot to talk about. The outbreak was Nipah. That's what we learned eventually. And these are the bats that carry Nipah. The risk factor we identified with this outbreak was climbing trees, particularly this tree. It's called Baroi, is the local name, but it's a jujube. So cases were more likely than controls to have been climbing trees. And we thought, well, maybe that's where they came into contact with a bat, but we didn't really know at the time. But that outbreak's also where I took this photo. We also thought this was another really good way that they could have come into contact with a bat. This is a date palm tree, and they're collecting the sap. In retrospect, we think that's probably how they got it. A number of the cases were date palm sap collectors in their household. But we didn't have the statistical power to see any differences between the two. Most of the cases were kids, and so that's probably why climbing trees was associated with the outbreak. But by the end of this week, I pretty much decided I wanted to be an epidemiologist. A few months after that, we were asked to come back out to a similar area because there were more cases what they thought might be Nipah. And so Jahangir and I went back out, and it quickly became clear that whatever it was that was causing this outbreak was spreading person to person. It's an epidemiologic curve that I drew out. Again, not much electricity. And we collected all this data on one day. So all these people were sick on the same day. They mentioned that there were a few cases. There were like 15 cases in the village where we landed. And all these people here who had onset recently all had contact with the same person 2 weeks ago. Nipah had never been described as being transmitted between people. So this was a little scary. But we set off to find all the contacts. So here's Jahangir and I on a boat. It was about an hour on the boat. Then we had to get a donkey cart to find the village. By the time we got there to one of the contacts we were tracing, he was already in a coma and near the end of death. But we found all the contacts. This was also Nipah. And it was one of the first descriptions of person-to-person transmission of Nipah virus. I have a suggestion for the school. As David will remember, ICDDRB had a staff cartoonist. There are a lot of cartoons with David in them out there in the archives. And so this was the cartoon of the Nipah outbreak in Faridpur, where I got to be a superhero. Ultimately, this is what the person-to-person transmission tree looked like. It was extensive transmission. And again, we got to work with some wonderful people on setting up infection control. And this is really where I first started thinking about pandemics and where they come from. In my time there at ICDDRB, I was there for 6 years this time, and that was just the beginning. Right? We set up surveillance systems for all kinds of infectious diseases. Our group grew exponentially. I became the lead for the surveillance and outbreak research group, and we went on to do dozens of outbreak investigations with the government of Bangladesh. And I want to tell you about one more. This one was also sudden child deaths. In the spring of 2008, 11 children with sudden onset of severe disease were reported. They all were sitting on the ground, many of them were very young, or playing at the time of onset. And the illness started with a sudden cry. They had fixed eyes, sudden weakness, respiratory distress, frothy discharge, unconsciousness, and cyanosis. Most of them were dead before they got to the health facility. we thought it was some kind of poisoning. We never solved this outbreak. It was really a crisis in the community, and families asked if they could do a postmortem exam on one of the children just so that they could understand what was happening. Everyone was very scared. But the answer was no. Postmortem exam is only if there's a legal case. If they suspect it might be suicide, there was no possibility of doing that. And so there was no way really to solve the outbreak. It was really frustrating. And it happened again the next year. Same time, spring. This was in two different communities, 13 cases overall, and there were 3 deaths. Most survived here because they were able to get to the community clinic on time, and they received atropine, and they recovered very quickly, which was another good indicator that this was some kind of poisoning. We thought insecticide poisoning. The same households also experienced deaths, dogs, cats, cows, at the same time. It took us 3 years to solve this, just to find the right labs to do the right tests, but we confirmed that it was caused by carbamate poisoning. Carbamates were the most commonly used pesticides in the fields around this village. So you can see it's the backyards, right, where the carbamate pesticides being used. Children play in the irrigation water. This is their backyard. They bring in the soil from the fields to build houses. This was a homestead being built there at the time, and that's where 3 of the children became sick playing on that homestead. These are the guidelines from using that pesticide. Remove domestic animals and all unprotected people from the area where you use it. The most commonly used pesticide in the country can't be used everywhere it's used. At least we got to solve that one. But we still have this problem of what to do when there are highly fatal, rapidly fatal outbreaks, and we don't have postmortem exam as an alternative. I came back to my desk, I remember from lunch one day, and this paper was printed out, left on my desk. At the top, my boss had written, "We need to do this." Postmortem exam isn't done in Bangladesh, or wasn't at that time, because of the sensitivities around organ removal and the need to return the body whole after death. But this paper, written by Dan Milner, showed a way that they were getting minimally invasive tissue samples to diagnose cerebral malaria. So we were trying to figure out, might we be able to use this in future outbreaks if we faced a similar situation? So this was the first protocol that I wrote as a PI, was a qualitative study to try to figure out if we might be able to do this. And when the first time we approached the IRB about doing the study, they said, "We're not even going to review this. You'll never be able to do this in Bangladesh." And we said, well, that's sort of the point of the study. If we can't, people are going to tell us that there's no way, right? And we knew the families who had been involved in previous Nipah outbreaks. I told you, we knew them really well. We followed up with the survivors. They understood what it was like to lose someone in an outbreak, and we thought they're going to be our best key informants. Let's go back and talk to people where we already have some trust and relationship. And here's what one of them told us, and this was a major finding. Well, I'll just note here in the photo, we wanted to show them the amount of tissue approximately that we were talking about taking to make sure they didn't think we were going to remove an organ. That's chicken meat in the photo, but it was used as part of the study. They said, when a person dies, the body will be buried within 5 or 6 hours after death. If you come after 1 hour, you can't collect the specimens because everyone in the house will be crying and mourning. If you come after 1 or 2 hours, then the relatives will be more approachable. If you come and then discuss the procedure for half an hour or an hour, then they'll give you permission, was her guess. So it looks something like this. So not a strong no, but a maybe, if you could get there really, really quickly. All right, it was time to get my PhD. As Steve McKenzie noted, well, come to Hopkins. I got a nice invitation to do that. So my supportive family here, my husband said, yeah, sure, I'll quit my job. Let's move to Baltimore. Why not? So July 2009, that's what we did. And my time here was also transformative. We had a lot of data in Bangladesh, but I knew there was something else we could probably do with it. And I really wanted to figure out what. So I came and I did that. And it was a wonderful time. My second year here, my husband, who's working for USAID, said, well, they're sending me to Afghanistan. And I thought, okay, so I could stay here, single parent, or maybe do something else. So we decided to do something else, which was move back to Bangladesh. Number 3. The idea was maybe if I talked to ICDDRB, they'd be willing to hire me back. And then maybe he could join us after his tour in Afghanistan was over, which is what we did. So it was really gratifying to go back and then apply everything that I had learned here. The group I joined was the Program on Emerging Infections, and ultimately I became the director of that program. I led a team of about 500 staff, including large field teams doing the studies that I told you about all over the country. We use multidisciplinary approaches. So this is just some of my team. We were at a conference representing ourselves well. Just in this photo, there are wildlife vets and health economists, microbiologists, physicians, anthropologists. And we all work together on solving problems. It was never a dull day in Dhaka. It was very hectic. I'm sure David could also attest to that. But exceptionally rewarding. And Hopkins impact. I did learn what to do with the data, things I didn't learn before. Alvaro Munoz's AMDAX class is one of my favorites. My class project ended up being my 3rd chapter in my dissertation. So take those class projects seriously. I was lucky enough to have an adjunct position here, and I used to come back and teach in the summer. I loved teaching. And so I always had a link with Hopkins, and I would always come back. One of my goals for coming here was also to find new collaborators that I really wanted to work with. Now, that's one of the funnest things about work, is finding good people that you love to work with. Justin Lessler and Andrew Osmond and I worked on this study on cholera shortly after I left, so bringing people to ICD-PRB. And Hendrik Salje and I worked together a long time on serosurveys in particular, and that work continues today. All right, you know what this map means. Something big's about to happen. So in 2015, the security situation in Bangladesh started to deteriorate, and we were really restricted on where we could go and what we could do. And at a certain point, there was only one place we could go out to eat out of security concerns. It was this lovely garden area. And in the summer of 2016, there was a terrorist attack on this place, because that was one of the last places that expats really frequented. It was really devastating for our community, and we were told we had 2 weeks to pack up and leave. So if you've got to leave, how do you decide where you're going to go? We're passport holders in the US, so we were going to come back to the US. But I needed a new academic home, and I remember writing to David and saying, so if I moved to Baltimore, you think we could work something out? And I'll always be grateful. He said, yeah, I think so. So we moved back to Baltimore. And I joined Hopkins in 2017. And that's what brings me here today. Now I'm going to talk about 2 big problems that stem back from my early work in Bangladesh that I still work on today. And one of these big, difficult problems is, how are we going to prevent pandemics? I'm going to talk about this in the context of Nipah. And here's why we should worry about Nipah as a pandemic threat. It has a very high case fatality rate of 40 to 70%. There's a wide distribution of the reservoir hosts. The bats that carry Nipah live across Asia, into Australia and even on the coast of Africa. So the reservoir host is widely distributed. It's transmitted through the respiratory route between people, which is not great. The R naught is 0.3, so well below 1, but in this study that we did looking at transmission between people, adults with difficulty breathing, their R naught is about 1. Wide confidence intervals, but most adults with difficult breathing who have NEPA do infect at least one other person. And we have super spreader events, as I already told you about. So is there a strain out there that is more highly transmissible? I don't think we want to find out. So let's think about spillovers. I want to propose to you that spillovers and targeting spillovers for prevention is a good way to prevent pandemics. A spillover is an infection in a new host. So from a reservoir species to a new host, it could be a human or another animal. It's a new opportunity for the pathogen. Most pathogens can't do this. Lucky for us. It's got to overcome all these boundaries for the spillover to happen, but the other good thing about this is that if we interrupt any one of these barriers, the spillover doesn't happen, right? So all of these layers could be targets for preventing spillovers, which could prevent pandemics. Spillovers are much more common than outbreaks. So this is showing just 10 years of NEPA surveillance in Bangladesh. We detected 50 spillovers when we started looking for them, but there were only 8 outbreaks during that time. So most of these are just one case. Unless you're looking, you don't find it. It's just a numbers game, right? Each time it spills over is one more chance for the pathogen. If we start looking, we'll find them, and we could target them for prevention. This is the distribution of Pteropus species that carry Nipah and Nipah-like viruses around the world. Where human cases have been observed are here, but you can see there's a lot of yellow where no human cases have been reported, and some of that is certainly due to surveillance bias. I'm sure all of you are familiar with primary versus secondary prevention. When I think about pandemics, to me, secondary prevention are the therapeutics and vaccines that we do pretty well. Our ability to develop vaccines is really, I mean, who would have imagined that we could develop vaccines, such good vaccines so quickly? It's great, but primary prevention is the spillover prevention, I think, in this context. And we're not really focused on that much at all, and I'd love to see public health move in that direction. So let me tell you about how Nipah was first discovered, and this story may also sound familiar. First, there was a large cluster of cases of encephalitis. They didn't know what was causing it. All right, well, by the time they figured out it was Nipah, they also realized that it had spread, sorry about that, way beyond the initial outbreak site. It had spread down from Malaysia down into Singapore, in fact. So by the time you figure it out, the cat's already out of the bag, so to speak, and transmission was ongoing. What's step number 3? Well, there must be a bat here somewhere that's responsible. So you start digging through freezers and you start collecting samples from bats to try to look for it. And then they found it eventually after a couple of years, Pteropus bats. And then finally, people get around to thinking, well, I wonder how this happened. I wonder when it spilled over and how that happened. By that time, there's virtually no way to figure it out. They were able to reconstruct in the discovery of Nipah that there had been an ongoing outbreak of Nipah in pigs. And so that's how the spillover happened. In Bangladesh, we were able to reconstruct and identify, how spillovers were happening over many years. It took many outbreaks to figure that out. Wouldn't it be better if we looked at these in chronological order and found the spillovers before the clusters were detected? So I would say that there's an ideal spillover detection approach and One Health investigation that would help us do this. And if we understand how the spillovers happen, we can prevent them. I think an ideal approach looks like this: clinic-based surveillance for febrile illness, and then patients with any risky exposures are identified. You can screen for known and unknown pathogenic threats. And if you find the spillover, that's actionable data from a public health perspective. Then you can take some action beyond just thinking, all right, this is a high-risk place. Or once you have the spillover detected in a human or an animal, you know something's happened and it's time to investigate. So that can lead to a One Health investigation that includes lab work like genetic sequencing, clinical presentations described in detail, and post-mortem exam. And then you've got to leave the lab in the hospital to do contact tracing, identify exposures, enroll controls, and sample livestock and other wildlife. Very similar to what we did even on my very first outbreak investigation. And that's like a symphony, right? You have a lot of experts working together to try to understand what happened in this one place in time. All of this leads to research opportunities at every single step, from diagnostics to surveillance methodologies, certainly over here on the right side. So what did we find looking for spillovers of Nipah in Bangladesh? You can see here on the right a clear pattern over time between 2007 and 2018. Some years have much more spillovers than others. Why is that? We still don't really know, but at least we can start to form hypotheses about the broader ecological drivers that may be important for Nipah spillover. So we talked about date palm sap before. This is a wildlife study we did where we put cameras in trees to capture how bats were drinking the sap. So you can see here this little face of a bat and his tongue. He's licking the shaved surface of the tree where the sap is coming out. It's sweet and delicious, and humans love it, and so do bats. Anthropologists help us understand how sap is collected, how it's viewed as a commercial product. We learned about how it was collected fresh from trees, and it's sold early in the morning. But during those interviews, they did tell us that fruit bats are a nuisance. So the people who collect the sap are trying to earn a living from it, and they don't like it when bats urinate in the sap or defecate in the sap, because then they can't sell it. So we knew right away then there was some alignment on keeping bats out of sap. It's something that we wanted to do for public health and that they wanted to do too. On the left, you can see this is a gachi. So this is someone who collects sap. So you can see they climb up the tree, harnessing themselves to the tree, and they shave the tree, and they're gonna put a tap in right there. And they told us, well, this is sometimes what we use to keep bats out. It's a bamboo net. We know how to make it. It's easy to make. It's cheap. It's acceptable and feasible because they were already using it sometimes. So we developed this intervention to try to stop Nipah spillovers of humans in Bangladesh. We developed interventions. I won't go through the trials that we did, but it did reduce sap consumption. And people were very happy to take up the intervention. It's not widely used now, however, because the government would prefer people just not drink sap at all. So they're very reluctant to propose that harm reduction strategy. As I mentioned, spillovers aren't just into people, they're also into animals. We did studies for a number of years where every time we identified a human who was sick with Nipah, we sent out an animal team to collect serum to see if we could find animals being infected at the same time. And in fact, we did. Cattle, dogs, and cats were all seropositive. And a study before this found a lot of pigs with antibodies that were at least reactive, cross-reactive to Nipah virus. So my guess is that spillovers into animals are even more common than in humans, and they go even undetected even more frequently. So we're trying to solve that now and figure out how spillovers happen into domestic animals and wildlife. Recall that in Malaysia, where this first emerged, it was an outbreak in pigs that then spilled over into people. So there's no reason to believe it's not happening here too. So we've launched a new study to try to figure this out. We're using serologic cohorts. So animals like this goat here, you can see the green tag that she's wearing. It says, I donated blood, the name of science. Have we've tagged them, we've collected blood, and we're looking for antibodies against Nipah and a host of other bat viruses that could be spilling over. We're going to resample them every 6 months. Now, to figure out how they were infected, we have some other methods. This figure is from Rebecca, the postdoc who's working with us. We put GPS loggers on the animals, of course. So in yellow here, you can see the pig herds. They're mobile herds, so we can see where they're interacting with the bat roosts that we have under study. They're in the red triangles there. This is a close-up of that map, so you can see again where the pigs are coming through our study villages, and the blue is a dog, where the dogs roam, and to see just how often they're interacting with the roosts and with one another. Now for the wild animals. We also use camera traps to understand which animals are underneath the bat roosts and which animals are feeding in the trees at night. So this is a fox hanging out underneath the bat roost. That's a jungle cat, also underneath the bat roost, maybe even hunting for bats. And this is an Asian palm civet about to munch on that fruit right there that you see in the background. So there's a lot of interactions that could promote spillover in this one area, and we're going to see what we can tease out. We've also launched a new initiative to curate all the evidence about bat virus spillovers. It's the Bat Spillover Evidence Compendium, which we call BATCOM. Cliff McKee made the lovely logo for us up there. And it's always fun when you say, I'd love to review all these papers. Anybody else want to do it? You have 40 other people or so who say, yeah, me too. So these are all the volunteers who are working on the project. And we're hoping to complete the reviews this year and launch our expert summaries of the evidence onto a website. And I'll keep you all posted on that. Now for the second big problem. How can we end child mortality? And here I'm going to start, this is a historical reference just for Bill, with John Grant, who can be easily described as one of the first epidemiologists, one of the first demographers. Both fields claim him. And in 1650, he wrote a report on the causes, the frequency and causes, as best they could determine, of mortality in London. And you can see this is a page from his bills of mortality. He counted the number of christenings, which is a way of counting, births, kids, the number of burials, and then a count that were probably deaths from the plague. Our data on mortality in many parts of the world still kind of looks like that, unfortunately. For all the hundreds of years that have gone by, the data haven't gotten that much better, but that's one of the other missing data problems that we're trying to solve. If you're not familiar with the Our World in Data website, you must go and visit. It's just a lot of fun. So this shows child mortality around 1900, and obviously there are some limitations to the data that go into this. But you can see almost the whole world was in a really bad place. That's the summary here. Okay, what about 1928? That's when my grandmother was born. It's a little bit better. What about when my mom was born in 48? Some improvements, but only in certain parts of the world. And what about when I was born? Okay, it's getting a little bit better. When I became a mom, even better still. And what about today? Even better still. No one's in the ugly red anymore, but still some really high, stubbornly high child mortality in certain parts of the world. And I present these not to suggest that we're done, not at all, but to suggest that, maybe in another generation or two, we can be done. And what can we do to accelerate that? This is just a fun figure of child mortality over time in all the countries where Emily's lived. So it's a random sample. But interestingly, child mortality in Bangladesh today is about where it was in the US in 1965. It's not bad. It's come down a lot. So CHAMPS, Dean McKenzie mentioned the study in the opening. It stands for Child Health and Mortality Prevention Surveillance. And it's a big Gates-funded grant, go bigger but go home kind of initiative of let's end child mortality. These are the sites. We have a new site coming online in Nigeria soon. Our study started in Bangladesh before I came to Hopkins, and I'm the co-director still for that site. One of the reasons we were chosen as a CHAMP site is because we had done so much early data on minimally invasive tissue sampling. That first study that I did. We went on from that first study I did to actually collect samples as part of surveillance, to develop the infrastructure, to develop consent processes. And so we were well placed when the call for proposals came out. The objectives of CHAMPs are to track definitive causes. So we're not just counting, we're trying to solve the problem of why children die. This is for child mortality and, in the sites that I already mentioned, but we also target stillbirths, and that's really new. Stillbirths aren't a part of global burden of disease estimates at all. They're not, I don't even think, a target in any of the Sustainable Development Goals. We just sort of ignore them. But not CHAMPs. We're trying to get some data. We disseminate high quality data to inform policy and public health action, and I would encourage you to look for CHAMPs papers. There are a lot of them. I'm not going to talk about all of them today, just a few points. We also want to use our sites to test interventions so that we can get some high quality data also about what works to accelerate the declines in child mortality. So these are the CHAMPs sites over time since 2000, and the child mortality, the proportion of children who die before the age of 5. As you can see, the curves are good, but again, we're trying to accelerate and we're trying to drive those down as quickly as we can. The minimally invasive tissue sampling that we use in CHAMPs takes samples from children under the age of 5 and stillbirths. If we get consent from the families, then we collect all these specimens post-mortem. We collect photographs and physical measurements of children, and of course collect whatever we can glean from the clinical record and then the verbal autopsy interview. And all those data, including pathology reports, go to what we call a decode panel. And this is a panel of experts in every country that reviews all the data available to determine the cause of death as best they can. They also make a comment about how the death could have been prevented. And those are the data that we use. So we have the surveillance, as I mentioned, we enroll cases, cause of death is determined, and then the data go back. They go back to moms and families first and foremost. And what we're trying to do at a bare minimum is make a difference in their lives on the next pregnancy, help moms get all the medical care that they need for a healthy pregnancy next time. It also goes to the healthcare providers in our area and of course to policymakers in the capital. The Bangladesh site is here. We have a health and demographic surveillance site that underpins all of our CHAMPs work. The population there is about 260,000 with about 7,000 births a year. So that's a lot of babies. And we have surveillance for illness at 3 different hospitals. Our consent rate for the MITS procedure, we were a bit worried about because it is such a sensitive issue, but it's increased over time. On average, we get a little over half of families that agree to the procedure when we approach them after a child dies. We talk about child mortality, child deaths under the age of 5. But in Bangladesh, most child mortality is really under the age of 12 months. So in light orange here, these are all the deaths that we've seen in that Bali Kandi population since we started. 800 are neonatal deaths, so that's within the first 28 days. Then from 28 days to 12 months were 164, and then age 1 to 4 years were 143. So that's the minority. Actually, the 1 to 4 years deaths, we understand pretty well. Almost all of them are drownings or are accidents. There's 753 stillbirths. So almost all that mortality is really concentrated in the perinatal period, stillbirths and very early neonatal deaths. So CHAMPS, and the end of the day is, at least in the Bangladesh site, is as much, if not more, a study of what happens to moms as what happens to kids. Because in the perinatal period, it's what happens to moms that matter. It's gotten a lot easier to be a mom in Bangladesh, and especially in our site. This just shows the age at marriage over time. And girls and women are usually pregnant within a year of marriage. So it's encouraging to see that marriage of girls aged 12 and younger has almost disappeared. But it's still very high for 13 to 15-year-olds. And that can be difficult, and that certainly has some negative consequences on maternal and child health. So if you want to take care of moms, what do you want to do? You want to get them to antenatal care. Well, Bangladesh recommends that women get 4 antenatal care visits. That's the red line we're trying to see here. Most people don't make it there. But in each year, so this was a study done by one of my students, Allison Bear, and she was looking at different types of hypertension in women who have none. They're far on the left. Those in green are ones that have a surviving neonate, and in yellow, they have a perinatal death. And so what you can see is whether the woman has hypertension or not, there's no difference in the number of antenatal care visits between those who have a good health outcome and those who have a poor health outcome. So what does that mean? You can go to antenatal care, but the quality is probably so low, it's not making much of a difference. So it's going to be about, if we want to end mortality, it's going to be as much about quality and facilities as it is changing women's behavior. This is a study done by another student I had here, Ananya Kumar. And she looked at the special care newborn unit, which is almost like, it's analogous to a NICU, but it doesn't have all the bells and whistles for sure. And this was over months through November, where we had records in 2018. And you can see the orange in the middle, that's the neonates who were discharged healthy and went home. Vast minority. In green are the neonates who died in that unit. And in blue, we don't know what happened to those kids. They just left. And it could be that they just left because the family thought they were going to die. It could be that they just left because they thought the child was better and no one was there to discharge the child. But if you compare them to these other groups, they look a lot more like the children who died than the children who got better. So we need some work on quality of care here too. And while we're on the topic of quality of care, we recently did some studies at the request of the director of one of the hospitals that works with CHAMPS to look for contamination in their special care newborn unit. And they swabbed baby beds, the aspirator and suction machine, medical trays, all the surfaces around. And the nasal aspirator tube that they put in the baby's noses grew Klebsiella pneumoniae. And that was resistant to everything we have except colistin. As it turns out, Klebsiella pneumoniae is detected in a lot of the babies that die, including perinatal deaths. And it's hard to know what to do with that. Some of it could be coming from mom, and I'll get to that in just a second. We intervened here, and the director said, well, we've got a lot of new aspirator tubes, just use a new one for every baby, and that was hopefully solved. So within CHAMPS, we've started a new perinatal infections working group. We want some additional data to really describe causal chains for infections, particularly in perinatal deaths. And we're looking right now at maternal colonization with gram-negative bacteria and scrub typhus. I'm just going to give you a couple of examples. This study was done by Ashley Stachinsky, who's now at CDC. And she collected vaginal and rectal swabs on admission for delivery in one of our hospitals, and then on discharge post-delivery. And as you can see, colonization is really high. Almost every mom leaving was colonized. And if she was colonized, so was her baby. That's not good. Scrub typhus is a known cause of perinatal death. It's a zoonotic infection. Mites bite rodents. The mites then bite people. It can be transmitted through the placenta and can cause stillbirths or perinatal deaths. We've had 9 cases. Only one was considered in the causal chain because our decode panels that review evidence said, but was the mom infected? We don't know that. What do we do with this information unless we know what happened to the mom? So we're going to try to start figuring that out. The cases were scattered around our surveillance site. And the real tragedy here is that this is easy to treat. Doxycycline is all it takes, and you recover pretty well. There are no diagnostics here, and this must be just the tip of a really large iceberg of burden of disease from scrub typhus. Still a lot of work to do. I want to end by saying something about mentorship because it is important. Catherine Yount was my advisor at Emory. I know, it's not Hopkins. She's a Hopkins grad, though. She taught me to write, and she encouraged me in quantitative pursuits. Rob Bryman hired me at ICDDRB, and he also started CHAMPS. So he gave me so many opportunities throughout my career, and is one of my favorite people ever. Steve Luby has been a mentor of mine since 2005, and taught me everything I know about leadership, about frameworks for thinking about values and how you apply that to your work, and about how to be a good mentor. Mahmoud Rahman was our counterpart. He was the director of the Institute for Epidemiology, Disease Control and Research for many, many years. And he taught me about how government public health institutes work and what the optimal relationship is between research and public health. Firdousi Kadri is one of the most senior scientists at ICDDRB and always took me under her wing, and she still does. Gives me good advice about career and about family. Shams Al-Arfin, another Hopkins grad, is my co-conspirator in CHAMPS and has been given me always the best advice, even when I didn't know I needed it. And Bill Moss. Bill's been my advisor here since I was a student. And now I get to sit next door to him. And you can imagine my joy because I can go to him for sage advice about any and everything, anytime. And this was the most fun slide to put together. So these are people who I would claim in some way or another as mentees. And I mean, they're a very glamorous group, but also, I mean, there's just really nothing like finding that spark and that interest in someone else and working with them towards that. And yes, it's a good part. One of the good parts. Here's some life advice, and you get what you pay for. It's free. This is quick. Rule number 1 is don't freak out. And you need that rule because everybody freaks out sometimes, but it's never going to help. It's never going to help the situation. It's never going to help you figure out a solution to your problem. Don't believe everything you think. It's very important in research because you should never be too tied to your hypothesis that you're not open to new data, right? It's also important in our personal lives. A lot of people suffer from maybe I'm not meant to be here, imposter syndrome, okay? Just because you think it doesn't mean it's true. Seek out evidence before you believe. Get the problems that you want. There's no life on offer that's problem-free. Just accept that. So get a really good set of problems that you like working on day in and day out. And I think that's what I like most about my life, is I got the best problems. I've got really good, important problems at work. And I've got the problem of trying to balance that with my kids and my family, which is really the best problem to have. And I was raised by some wonderful people. Sorry. I wouldn't be who I am without them. And these people make the highs in life even higher and the lows bearable. Thanks. Wow.
Truly amazing. Yes. First question.
I've been watching this for a long time. The Peace Corps has been the origin of so many.
We got to get you on recorded.
The Peace Corps seems to be an origin of so many people in public health and clinical medicine. Has the Peace Corps retained its size and mission?
I'm not as up on those details as I should be. It certainly has the same mission, and it's certainly still active in many, many countries. I hope so. I hope so. I have some of my best friends in the world from my Peace Corps time. Some of them are even on the call. It's a good group. I would encourage anyone who's considered it.
Yes.
Oh. Where are we?
Right over here. Oh, I'm sorry. No. I think you pulled rank.
Okay, sure,
Yeah.
sure.
I just wanted to, since I was in Bangladesh when Emily was trying to figure this out, you know, when she went over the first few slides and said, well, of course it's in the vats. We didn't know that. You know, at that, I think we know so much more about bats now than we did at that time. And I recall some of the case control studies, and, you know, you're looking at a lot of different hypotheses. I think another point I'd make is that the fact that Emily and the people that she worked with found and, you know, understood that this was Nipah, that occurred because they were there and they were looking. But I'm sure, and in fact, we know that these outbreaks were occurring beforehand. So these were going on, but the right people were not there to be looking for it and to know what to do. And so sometimes, and particularly I think in high mortality areas like Bangladesh was, so many things can be happening and we don't recognize it. And so you know, it seems like, and as I recall, we were also worried at the time about bird flu. And I think you had the one slide about how we were looking at that, and they say, well, can we study your chickens? And they say, well, yes, but they all died last week. So, you know, there's a lot of red herrings that can go on when you're trying to focus on something. But anyway, no, it's a fantastic story of how you really honed in on Nipah. Yeah.
Thanks, David.
Talk, actually amazing, and actually to follow on my colleague there, you know, this theory is One Health, right? I mean, it's this connections, and what was obvious now was really exploratory even back then. Maybe you could elaborate a little bit now with, you know, we have a jump from Wuhan and animals that are going on to the more current one, but this continuation of really thinking about the colleagues that you brought on and working with that were not only the vets, but the anthropologists, and just how to engage this in an approach that we can be proactive, because I bet something else might come along there. Just your thoughts on that.
It's, I mean, yeah, the next things are spilling over now. It's really hard to work across disciplines because people speak different languages. We use the same word and mean very different things by it. Sometimes there are silos, administrative silos and organizational silos that prohibit people from working together or sharing data, which is really crucial and important for having a shared understanding and bringing a lot of knowledge together. I think ICDDRB was a really rare place because we were bringing everyone together on the same team, which is rare but should happen more often. I'm planning to develop a new course this year that will try to teach people how to do that. So and develop an appreciation for all the disciplines and what they bring to a One Health investigation, and promote that kind of collaboration. So how should the virologist think about the anthropologist, and where do they connect? Interesting questions like that. But there's a much better understanding of that type of work now than there was then, for sure. I hadn't even heard of the term One Health when we were doing those studies. Like, that wasn't even it wasn't a term. It was just so obviously the right approach to figure out what was going on. And people know more about it now, but I think the true collaboration is still much rarer than it should be, obviously.
I hope your first week of that course has acronyms killed, because across disciplines, it's really that challenge of the same letters sure do mean different things.
So we're getting a question as to whether or not this is going to be online as well as in person.
The course? Oh, we are going to launch it on Coursera.
Okay.
This will be a Coursera course. Ira and team are going to help us with it.
Fantastic.
He's already agreed and now in public, so have to. No backing out.
There is a question, Emily, online. It's from Juanita Lozier. Is there a potential method of pasteurizing the sap that can happen?
It's a great question. We get that a lot. The short answer is no, because that changes the taste. So it's this cultural experience. You get it fresh in the morning and it's cold and it's sweet. And anything you do to change that, it's no longer fresh date palm sap. Almost all sap is boiled and made into molasses. So that's fine. But the fresh, it's really difficult. It's really difficult to change at all in a way that would kill the virus. Interestingly, with the internet and new infrastructure, sap is now being sold frozen online. So there was a case last year of someone who had purchased sap, drank it, and got Nipah. Because what do we do with samples to get a live virus? You freeze it right away. So that's going to change. The context of Nipah is changing. It's going to change in the distribution of where we see spillovers. The distribution of ventilators during the pandemic was great to help people survive. It's also a great way to have a super spreading event. So the context is changing.
Sure. Other questions, either here or online, if you just want to raise your hand, or, well, I guess we can't see your hand.
Sorry.
Just put it in a chat. Any other? Bill, you must be proud.
Very proud. But I did nothing. Everything. She was the easiest grad doctoral student to it.
She's a force.
Yes, out of the way.
All right. Well, if there aren't any other questions, again, Emily, that was just amazing. And it was I loved how you told your life story, and it was just incredible. And thank you so much for today and for everything you do. And we look forward to the new course. And with that, I would love to invite everybody out to the Wall of Wonder for a reception. Unfortunately, the folks online can't join us. Do you want to introduce? You have some family online. Do you want to?
Well, yeah, Dr. Steve Johnson, I see there on the screen.
Yeah, we don't see.
Yeah. Yeah.
Yeah, it's
So
hard
proud
to
he
show
could be
everybody
there.
online. Yeah.
Yeah.
But I wish you could all join us, those of you online, but unfortunately, the technology is just not advanced enough. One day. All right. With that, again, thanks everybody for coming. And please join us at the Wall of Wonder.
Thanks.